Hi again, everyone. It's 20 past, so I hope you've all been able to get drinks and whatnot during the break, stretch your legs. Thankfully, I managed to fix my screen sharing issues. Mac OS was just a bit funny with permissions for Chrome and had seemingly randomly taken them away again, but thankfully that's been dealt with. So I can now share the material, which you should be able to see here on the left. And also, when we get to it, I can also show you my terminal, which isn't currently logged into ARCHER2, but will be whenever we get to the point that we need to do it. Okay, and the recording's going in. Thanks, Julian. Okay, so with that, we can move on to the next section, which is an overview of the ARCHER2 system. So I'm going to move this over. I think that should be large enough. Let me just make it just a little bit bigger for you all. So yes, so the next section is an overview of the ARCHER2 system. Let me just actually, oops, didn't need to do that. These buttons get in the way a bit. There we go. Okay, yes, so we're just going to spend a little time here talking about what actually goes into ARCHER2, what makes up the ARCHER2 cluster in terms of hardware, how it fits together, and understand how it works together. So making our way on through it. So the ARCHER2 cluster, so ARCHER2 is the name of the service, but in terms of hardware, ARCHER2 is an HPE Cray EX system. So this was back just when Cray was still Cray before it was bought and became part of HPE. This was being developed then as what was called a Cray Shasta system. That was its what would you call its developmental name. Now it's a mature product being sold. It's what's known as an EX system. This is the market name for the cluster. Of course, along with the hardware itself, HPE Cray provide a lot of software. We'll be talking about that this afternoon. This comes into the development environment that you'll all be needing to know how to use when it comes to actually building and using your code. But in terms of hardware, there are a number of different node types. So the ones that we care about as users are the login nodes, which are the ones which we land on when we SSH into the system, the compute nodes, where we actually run our jobs, where we do all the interesting work. On the back end, you might hear the compute nodes being called. And the data analysis nodes, you might also hear these being called things like the serial nodes, which are used, designed principally for pre and post processing. There are other types of nodes, but we don't see those. These are things like the nodes used for the maintenance of the system. They give extra access points to people at HPE and the like, and of course the nodes which help manage things like the Lustre file system and such like. But these are the nodes which we as users can, at some point if we want, either run things on or SSH into and use directly ourselves. All of these nodes have the same type of processor. That's an AMD EPYC Zen 2, 7742 is the model number processor. The cores on them have a clock speed of 2.25 gigahertz, and each core, and there are 64 cores on each of the physical chips. What's important to note is that the nodes are all dual socket, so there are two physical processor chips on each of the nodes, meaning that each node in total has 128 of these cores. Just a little down, we have a slightly simplified diagram, but one that should give you an idea of how the system is laid out. Again, just taking into account the things that we as users care about. So there we are on the left. We're the people here. We want to log in using SSH to work, compile things, run jobs, upload and download data. So we SSH in and we land on the login nodes. The login nodes, you can see, are connected to all these file systems. So these cylinders down here represent the different file systems. We'll talk about these a bit more in a second. The login nodes have access to everything. The data analysis nodes can be accessed through Slurm. They also give you access to everything, and you can also move data in and out from ARCHER2 using those nodes. When we want to run our jobs, we then go through the Slurm batch system. We'll be talking about Slurm this afternoon. We can write job scripts that say how many nodes we want, for how long, how many MPI tasks to run, and then what should those nodes be doing? Which simulation packages should they be running? What work do we want them to do? We send that into the Slurm batch system, which automates the process, and when it decides it's time for our job to run, it will send those commands that we've written off to however many compute nodes we requested, and it will run them there. The compute nodes, though, you can see a difference here. The compute nodes are only connected to the work and solid state storage. They don't have access to home. We'll talk about this a little bit in just a second as well. So the compute nodes are really the main point of ARCHER2. The compute nodes are the nodes which actually do the work. This is where our interesting science gets done. In total, there are 5,860 compute nodes in the system. So if we multiply that through by 128 cores per node, that means we've got just a little under 750,000 compute cores. That's quite a lot, isn't it? In the whole world, I think, I'm not sure if a top 500 list of supercomputers has come out since. It hadn't a month or so ago, maybe more recently. But as of the November 2021 top 500 list of supercomputers, this meant that ARCHER2 was the 22nd, I think, largest supercomputer in the world. And in terms of pure CPU-based supercomputers, it was 5th in the world. The reason I say pure CPU is because if you're interested in this at all, you'll know that a lot of supercomputers now include GPUs as a component. And Julian's just said the next one is in June. So we'll probably see some updates then, but as of the last list, yes, ARCHER2 is 22nd overall and 5th for pure CPU systems. Of those 5,860 nodes, there are 5,276 standard nodes. Standard means that they've got the standard amount of memory, which is 256 gigabytes. And another 584 nodes are high memory nodes with 512, so double the amount of memory. A big part of getting one of these new fancy HP Cray EX systems was that it would have a high performance Cray slingshot interconnect, which is something fancy and new. It means that each of the nodes have 2 network interconnects each, grouped into groups. So every node within a group can talk directly to every other node in the group, and every group can talk directly to every other group. I think this is a dragonfly topology. And as I mentioned just before, we access control to the compute nodes via the Slurm system. So just to compare to Archer, ARCHER1, if any of you are ARCHER1 users, in terms of processors, the cores on ARCHER2 are actually a little bit slower in terms of clock speed, but we have a massive difference in throughput. We've now got 128 cores per node, rather than the 24 cores per node that were on ARCHER1. NUMA regions, some of you won't care too much about this, but some of you who use in particular things like OpenMP will care. There are 8 NUMA regions per node, 16 cores per region. So that really means that there are 4 NUMA regions per physical CPU per socket. If you do use OpenMP at all, for you, that means that you won't want to have OMP num threads more than 16. You won't want to use more than 16 cores within a single threading group, because then that means that your threads will be on different NUMA regions, and it will take a little bit longer for the communication to get done between them, because they'll be accessing memory which isn't quite as close in terms of NUMA distance. So that's just something to bear in mind for those of you who do use OpenMP and threading, that you really want to restrict yourself to at most 16 threads in each threading group. We've also got a lot more memory per node. We've just been talking about that, but we've basically got about 4 times as much memory per node as Archer. But because we have so many more cores at the same time, this means if you do run with 128 tasks per node, you can find sometimes that memory can be an issue. Not always, but if you do run particularly memory hungry applications, you may find that a little under 2 gigabytes of memory per task can sometimes come in to be something you need to bear in mind. The memory bandwidth is also much higher, and the interconnect bandwidth, this is the bidirectional thing. This is also saying about having 2 interconnects per node, is also a lot higher. The new Slingshot network is a big improvement. So we've spoken a little about storage up here. Remember, here are our disks in this this diagram. So now let's actually talk about different storage systems available on ARCHER2. So really we've got 4 available: the home file system, work file system, a solid state storage, and there's also the RDF AAS. That's the Research Data Facility as a Service. We'll talk about them one by one. For most people just now, the home and work file systems are the important things. So the home file systems are available on the login nodes only. I should actually say on the login nodes and the data analysis nodes. So they aren't available from the compute nodes. This is the important thing to remember. So this means when you're on ARCHER2 and you're developing code or you're setting up simulations, what you need to remember is that anything you need for a job shouldn't be in home. If it's going to run on the compute nodes, the home file system is not mounted on the compute nodes. So if you make any reference at all in a job to something on the home file system, you'll get an error because it's invisible. The home file system is not particularly huge. So its main purpose here is the storage of, as it says, critical source code and data. So it almost acts in a way as a backup of the work file system, in a way. What's important as well is that the home file system is backed up regularly. I believe, I actually think it's possibly, I think we actually talk about accessing the backups tomorrow. Don't worry, we will talk later on about how to get the backups if you do need them. But really, anything really important that you do not want to lose can go on the home file system. It's huge, so you mustn't have to store a vast amount of it. There will be quotas there from your project that you're a member of that limit how much data you can put on the home file system. So yeah, there's a total of 1 petabyte, and as we'll see in a second, that's much smaller than the work file system. All users have their own directories at /home, /project ID, /subproject ID, /your user ID. So this is because everyone on the system with an account is a member of a project, and within that they're a member of a subproject. So this is just an easy way to keep everyone's work in their own project. So if you have a username of a user and you're in the project TA062, this is the project for this course. So if you've requested an account for this course, that's the project you're in. You'll have done that while you'll have put this into the safe while you were getting your account. Then your home directory, the directory that you find yourself in when you log in, will be at /home TA062 TA062 /a user. We'll talk about this second one, the subproject, in just a second. There's a little section down here. Yeah, so just something quickly to note. Sometimes people talk about the home file system and the home directory, and indeed they do the same about the work file system and work directory. When someone makes a reference to your home directory, they are specifically talking about this directory, or this one for a generic project that you're in. They aren't talking about /home. /home is the root directory for the home file system, but it is not your home directory. And if you try to do anything within just /home, you won't be allowed to because you don't have write permission there. Anything you want to do in your home file, in your home directory, needs to be in this directory here. And you can always get there if you just use the home environment variable, or if you go to cd tilde, or even just type cd and press enter. Something you can always do is to go to that page Julian showed earlier, your account page, and you'll see there what the quota is for the home file system. Because it is only 1 petabyte, I say only 1 petabyte, but that's shared between a lot of people. Because there is only 1 petabyte shared between a lot of people, the quotas will not allow you to store everything in the home file system. So every project has a quota that's to be shared between all the users on that project. So all of us who've now got projects under TA062 are sharing some quota for the home file system. And if we collectively hit that quota, then we collectively will not be able to create any more data, to use any more storage on the home file system. Something to note, subprojects. So this second part here in the path to your home directory. So if you're in a big project, I think in particular things like the high-end computing consortia choose to do this. So there are some projects which have hundreds of people on them, and to try and keep things fair between their potentially hundreds of users, the project managers or the PIs may choose to split their resources into multiple subprojects. So these will have a code which will start with the main project ID, but then be followed by the name of the subproject. So the example here is that we might take our TA062 project that we're all members of if we've got accounts for this course, and so I would be able to do this because I'm listed as a project manager, could choose, if I wanted, to create a new subgroup of it with the name RSE, and that would then have a TA062-RSE subproject. What I might then choose to do, and I think this is a little more common, is that I might choose to give some of you access to compute resources in that subproject. Or I may also choose to add some of you to that subproject and say, okay, user 1, I'm giving you, you and everyone else in this subproject 50 gigabytes, let's say, just pick a number, of quota. That's specifically for you. And then everyone within that I'd put within that subproject would find those, would be able to use a directory with their username again within that subproject directory. But only the people added to that subproject. So yeah, your home directory won't be changed if that happens. So if you want to use that specific disk quota set aside for you as a member of that subproject, you need to specifically move to this directory. I'm not actually sure in practice how many project managers do this, but certainly some do. So it's something to be aware of. If your project manager does choose to assign disk quotas in this way, you should be aware at least that to use that quota, you do need to move into your directory within the subproject directory. Talking about the work file system. So this file system is available everywhere, and it's very different from the home file system. The home file system is essentially a backed up network file system. Work, on the other hand, is a Lustre file system. You may have heard of Lustre previously. It's a high performance file system. It's designed specifically for to be performant for massively parallel applications. The difference is a normal file system, say you've got a Windows computer and you're using, what is it, NTFS, I think. This is just designed for, a single disk, a single SSD, whatever, being accessed from a single machine, probably just writing one file at a time or a few files at a time, perhaps from a few tasks, a few threads. When you're working, when you're working with a massively parallel application, you might, on the other hand, find yourself with thousands, tens of thousands, hundreds of thousands of parallel tasks, and perhaps they're all trying to write to one file at the same time, or perhaps they've all got 1,000 files open and they're trying to write to them all. The scale is much larger, and Lustre is designed to be performant in that situation. The way it actually works is that it's a little bit like, if you've used RAID, it's a little bit similar in a way to RAID storage, in that the data is spread across multiple disks. These are referred to in Lustre terminology as object storage targets, and they're held within what are called object storage servers, so OSDs and OSSs. So you can have a single file potentially held across several disks, several physical hard disks, and the way that this is hooked up to the network allows potentially thousands, as I say, of parallel tasks to read and write from this file simultaneously at high speed. At the same time, there are metadata servers within Lustre, so completely different servers that have hard disks of their own, but on these disks they don't store any of the actual data within the files. They just store the metadata. So I think that goes as far as the file name, its location, size. I can't remember if permissions are stored on the metadata servers or not, or if that's part of the object storage data. But certainly location and size are stored there. And together this works. This is all hooked into the fast ARCHER2 network. Together that means that this file system is highly performant for parallel applications. Something that's important to note is it's 14.5 petabytes compared to the 1 petabyte for the home file system. And this also means that it is not backed up at all. So anything that you have on the work file system, you really do need to be aware of it. And if it's important, you need to make sure that it's backed up. Whether that means putting copies of things in home or moving it off-site to storage you have elsewhere, this really is important that you keep the data there safe. In terms of actually finding your work directory, it's exactly the same as your home directory. It's just that where your home directory started with /home, it now starts with /work. So, so maybe I'll quickly show you this. Maybe this is a good opportunity for me to just quickly log in to ARCHER2. Are you able to see that on the right? I think I'll make it a little bit bigger. So if I SSH into ARCHER2, so this is just the command I'm going to use. There is a faster way of doing this. I can maybe show you tomorrow if people are interested in the afternoon session. This is probably how a lot of you are doing it. So I'm just saying I want to SSH with my username, which is WLTA062 at login.archer2.ac.uk. Then I'm using the -I flag to tell it which key to use. This should go through, and then it's going to ask me for my password. And I'll just quickly grab my password, which I have in a password manager because there's absolutely no way I could remember this. And I'll copy it in. And there I am, I'm logged into ARCHER2. Oh, it's taking a second for the prompt to appear, isn't it? Maybe there's a lot happening on the system just now. But we can see we've got, unfortunately, a slightly mangled message of the day. Here we go. So I'm logged into ARCHER2. So if anyone can't see this, please say so in the chat and I'll make the text bigger again. But here I am. Here's my username, WLTA062 at LN03, means that I'm on login node 3. If I do pwd, here I am in my home directory. And I can do that, you know, if I were to do cd home, I would just end up in the same place. And if I wanted to move to my work directory, well, I could just do cd/work ta062/ta062/ my username again, WLTA062. And here we are. I'm in my work directory. So as I say, anything at all, and I really do mean absolutely everything that I want for a job has to be in here, has to be in /work /ta062/ta062/WLTA062, because anything in home will not be visible because home is not mounted on the compute nodes. So here I am. This is my work directory. Oh, and here's a reminder. Yes, home file systems are not visible from the compute nodes. So something you may want to do is to check on the safe. Let me see if I can quickly do this. Do I have the safe up here? Yes, I do. Oh, and I'm even logged in. Fantastic. So if I check this account on the safe, this is just the same page Julian was showing you earlier. Should be able to see here our disk quotas. So here's TA062 resources, and we can see what we have. So home, we have a quota of 10 gigabytes, and on work, we have a quota of 100 gigabytes. Something else we can also see here that's useful is our budget. We'll talk about this later on when we're talking about SLAM. But you can always come here and check your quota, and you can also use commands like this here, lfs quota hg ta062/work, and I'll just copy that across to run it because I'll probably make a typo if I type it out myself. If we run that, we get some information here. At the moment, everything is empty, so we don't actually find much. But this is a way of checking while you're logged in the disk usage. So there are actually quite a lot of LFS commands. Some of them are not really things which we as users need to worry about. Some of them are useful. This is one of them. So we're saying here, raster file system, we want the quota, human readable for group TA062 on work. So this is saying for the Unix group TA062, what's our quota on the work file system? And at the moment, everything is empty. If we actually, so here's an example of if it were chock full of things, we might find instead that we'd used, say, 17.24 terabytes out of 21.95 as our quota. And we can also do this. Changing the G to U means that we'd then be checking the particular usage by a given user rather than across the group as a whole. But something that is important to remember here is that these quotas do apply group-wide rather than just for individual users. So anyone within the project, or if it's been set up within the sub-project, contributes to the quota usage of that project or sub-project. Okay, let's make the material a little bigger again. So solid state storage is available. It's on the system. We're testing it at the moment. I don't believe people have access to that yet, but it should be made available soon. So this is there, and it's designed to give you basically the highest read and write performance. So this is particularly useful if your application is I/O hungry. If you need to do a lot of reading, or if you dump a lot of data during the run, this can really help speed things up. The access is going to be through Slurm. It's using what's called the burst buffer system. So there's some burst buffer BB protocols will go through Slurm. And how it will probably work, I say this is not entirely accurate here, so this is going to be coming soon, but how it will probably work will be that at the beginning of the job, you'll request a certain amount of space. You'll probably then stage input onto the solid state storage. So you'll just essentially run copies from the work file system onto the solid state storage. You would then have your application run, reading that input from the solid state storage. It would produce output, writing to the solid state storage. Remember, much faster because solid state storage does provide faster write speeds even than a Lustre disk. And then at the end of the job, you would run some cleanup commands, essentially moving everything back to the work file system. So this isn't available yet, but it should be soon. And at that point, there will be documentation available on the ARCHER2 website. The final source of data, I guess we'll call it, is the RDF-AAS, the Research Data Facility as a Service. So if you had data on the RDF before, so this was a service which ran previously, and if you were a member, particularly probably of one of the consortia again, you may have had data on the /EPSRC or /general file systems there. It isn't guaranteed that you did. If you didn't, you can safely ignore this because it doesn't apply to you. But some of you may have had this facility available to you. And in that case, you would have had data in a directory like this. And what you can do is you can access them from the login nodes only. So if you had data stored there, you can still access that. But it's only available from the login nodes. So you would need to copy anything you needed into the work file system before using it in a job. Something you can do if you want to share data with other users, there are two ways of doing this, and it depends where you are, where the other person is in terms of the project that they're a member of related to you. So the first situation you would consider is if you want to share data with other users in the same project. I should actually say the reason we need to think about this is that your home and work directories are only readable by you. A lot of people, I think, on ARCHER2 do actually have things that they can't really release publicly. So allowing other users to tool through your directories would not be a good thing. So by default, all of your directories are only readable and writable and executable. All the permissions are only set for you. But if you do need to share anything with other users, then we have these shared directories. So people in the same project as you will, of course, have home and work directories, which are exactly the same as yours, except they'll have a different username at the end. So a user might be there, and then there might be a user2 also there. And if they wanted to share data between one another, they would use the shared directory in the same subproject directory. So let's just quickly take a look here again. Here I am still on ARCHER2, and I'm still in my own work directory. If I go up one level into the subproject directory, which is just still TA062, then I can see everyone from among us as a group who has an account on the project. If these usernames are all of you, you probably recognize one of them. But there's also this shared directory here, and I can go into that shared directory. And in here, I can, just vim some data.txt, and I'll just put in hello, because why not? And that will then be there. The file system seems a little slow at the moment. That's interesting. So yes, so now there's this file here, some data.txt. And what I then just need to do, if I check with ls-l, I'll see that it still doesn't have the right permissions, but I can change permissions with this chmod command. I'll just copy that. So I'm just giving read permissions to everyone in the same group, and taking away, in case they're there, read, write, execute permissions for anyone else. And if I do ls-l again, some data is now here. Only I can modify it, but all of you in the group, in the project, can now read some data.txt and copy it elsewhere if you want to use it. So you might have, in this example, you might have a directory called interesting data, and you can just copy that into the shared directory, change the permissions to make sure that others in the project can read it. Remember, everyone in the project is a member of the TA062 group, so you just want to change group permissions, and then they'll have access to it. If, on the other hand, you wanted to give data to anyone outside the project, then instead we need to go to a different shared directory. So this is the shared directory within the TA062 subproject directory. If we just go into work TA062, then we've only got two directories, the TA062 subproject directory and another shared directory. And inside this directory, we can put anything that we want to share with anyone at all on ARCHER2. So anything in here is accessible from anyone with an account on ARCHER2. So again, we could create another directory and we could copy data into there, and then we would modify the permissions this time with these geo plus rx, and that means group and others. So this would give anyone at all permission to read, and if there are execute permissions, execute whatever is in this example, more interesting data. Yeah, and equivalent directories exist on home. So if I move to my home directory, so here I am again in the TA062 directories on the home file system, and in my home directory WLTA062, I can just go here. Here we all are again, and there's another shared directory. Finally, just before lunch, we've only got a little bit to go, thankfully. In terms of what software is on ARCHER2, and we'll be talking about this more, this is going to be a big part of what we talk about this afternoon and tomorrow morning. So ARCHER2 runs what's called the Cray Linux environment. This is a Linux distribution based on SUSE Enterprise Linux. If any of you use OpenSUSE, this is similar again. We run officially the bash shell. There are other shells available, but it's possible, and in some cases perhaps likely, that not all of the software, particularly the Cray software, will work in those cases. And of course, Slurm has been mentioned a few times. So HP Cray, as well as just giving you the hardware and the operating system, they provide a lot of software in what's called the Cray programming environment. This is what we'll be talking about this afternoon, the development environment. This contains lots of pieces of software which work together to the idea is to make development easy. I think it takes a little getting used to. It's a little different, but I think once you've got the hang of it, I think it does actually succeed at that. So on the system, we've got the GCC compilers, the Cray compilers, referred to as CCE, Cray Compiling Environment, and the AMD compilers, that's AOCC, that's the AMD Optimized Compiler Collection. For parallel communication, most of the time we'll be using Cray MPI, which is based on MPICH2. There's also OpenMP, global arrays, co-array Fortran, and the like are available. I think you can use Chapel as well on the system if you're interested in Chapel. It's important that we use this. So I think some people have installed OpenMPI themselves, but I don't think that's guaranteed to be using all the libraries that really tap into the hardware, this special slingshot network that's available. So I think if you can, just going with the default Cray MPI is definitely the best option. We've got libraries providing things like BLAS and LAPACK and the like, FFTW, HDF5 and NetCDF are available. Then we've got some debugging and profiling tools, GDB for HPC, we'll be looking at tomorrow. CrayPat, again, tomorrow we'll be looking at how that works. We have an optimized Python 3 environment, which comes with NumPy, SciPy, MPI for Pi, and Dask. Again, these are all optimized for the Cray system, as well as an optimized R environment, much the same, designed for use on this system. From ARCHER2, we have a few differences. We didn't have the Python and R environments there. ARCHER had Intel hardware. This is AMD, so now we don't have the Intel compilers and DIMKL. And at the moment, we don't have ARM Forge. However, this is incoming, so this should be made available to users, I think. I want to say within this month, but I'm not sure, but certainly soon. So these are alternative debugging and profiling tools. So these are actually on the way. for you to use if you want. And so all of that software comes directly from HPE Cray. The ARCHER2 CSC service at EPCC, so that's what Julian and Alexei and I work as members of. We've installed a lot of other stuff which hopefully people want. This is mainly things like simulation software and numerical and scientific libraries and some extra tools. So this is really what the package users, I guess, want people to log in and immediately start running simulations. So things like CASTEP, ChemShell, lamps, and WChem, VASP. I guess everyone seems to run VASP and ARCHER2. And yes, some other things. These are all materials, biomolecular modeling, things like GROMACS, Code Saturn for VASP, OpenFOAM, and then some system software, MIT, GCM, NEMO, as well as some extra libraries, as I say, Boost, GSL, PETC. Finally, we have some extra tools, things to help people, CDO used for processing climate data, PowerView for post-analysis and the like. Something to be aware of is that if you want to use any of this software and it's licensed software, you do have to provide a license of your own. So things like VASP and CASTEP, I guess, are the examples here, the main examples. But if it's a piece of software that you have to have a license for, then you won't be able to just use it. So they're made available on ARCHER2 through Unix groups. If you aren't a member of the group, you won't have read or execute access to that software. To get access, you go through the safe again. I'll just quickly show you. So here's my WLTA062 account. If I wanted to access, say, I don't know, let's say I want access to VASP, I would have clicked on, sorry, I should have shown you that. I would have clicked on this request access to button, access to package button here. Just click on it, and then you choose what you want. So CASTEP, ChemShell, OneTep. Let's just say I want access to VASP 6. Click on select. And then I would provide details of my license here. So please supply your email address, registered for VASP 6 access. I just write my blurb in here and then click on submit. That would create a query. Those details I provided would be checked, and then if it's all okay, I would be given access to that software. Finally, as a single note, you can run Singularity containers if you're interested. At this point, given it's only 10 past 12, I think we can sort of skip this. This is easier to do. It doesn't really make sense, I think, to do this so much in an online setting, but if we were in a room, I'd have us all chatting about this. But this does remind me, Julian was able to sort out during the break the Etherpad, so the Etherpad is online now. So if we come across any sort of useful tips or things to remember, I'll be adding those in there. I think the main thing I can think of now is that I'll put our reservations in there later on this afternoon after lunch, once we get started running jobs, to let you all run jobs on the reservations if you want. Okay, great. Oh, and there's the link just in the chats now. Cheers. Okay, great. So with that, we're 10 minutes behind schedule. I don't think that's a problem. So I think we should just take that full hour for lunch so that we can all get a break, and we'll come back. We'll come back again after lunch at 10 past 1. I'll hang around just now for a bit, at least. If anyone has any questions, um, please do ask them now. I'm happy to do so. Again, particularly if anyone's having problems getting logged in, because our next session, I believe, oh no, our next session is the development environment. Okay, but after that, we will be running jobs on ARCHER2. So really, this is your major opportunity now to get logged in if you aren't. Julian, okay. Okay, great. But still, I'll hang about for a bit now before getting my lunch. So if anyone does have any questions or just wondering thoughts about things, please go ahead and speak up now or put it in the chat, and I'll be happy to answer or help you out. Otherwise, I'll see you at 1:10.